All right, so I'm going to quick go over these notes to finish up 6.5 so that we can start with 6.6 on Monday. So again, I'm going to just explain these notes, and then if you want to write them down after I'm done explaining it, pause the video, feel free to do that. So question 2, we want to figure out what is the most, if our conclusion is going to be valid or not valid. So given the information. Remember, when we're doing this, we need to use our hierarchy. So we can look at ABCD, and the only thing we know about it right away is that it's a quadrilateral. So we got to go down from there to prove what we want to do. So in part A, our conclusion is it's a square. So in order to prove that, I need to know it's a parallelogram, and then I need to know it's a rectangle and a rhombus, and then I'll know it's a square. So that's kind of the way we're going. We've got conditions for parallelograms, we have conditions for rectangles, and conditions for rhombuses. So AC and BD bisect each other. So we know that our diagonals are going to bisect each other. And then we also know that AC is congruent to BD. So we know that our diagonals are congruent to each other. So they're all going to be, all those parts are going to be the same. So this is going to be a not valid that it's a square. We do know that ABCD is a parallelogram because we know that our diagonals bisect each other. So this part right here tells us that it's a parallelogram. And then we also know it's a rectangle because we know that our diagonals are congruent to each other. That's that piece of given information. But there is nothing here that tells us that it's going to be a rhombus. So therefore, we can't prove that it's going to be a square either. So in order for it to be a square, we would need to know that it is also a rhombus. So one of the rhombus properties would have to be true. Part B, once again, same process. We got to prove it's a parallelogram and then prove it's a rhombus. Next one says, given AC is perpendicular to BD, which tells us our diagonals are perpendicular, which means they make right angles, and that AB is congruent to BC. All right, so for this one, once again, got to start with the parallelogram, then move on to rhombus. So this one's going to be not valid because there's nothing here that tells us it is a parallelogram. We do have two conditions to be a rhombus, but remember, for it to be a rhombus, we need to know it's a parallelogram. So it's just not valid because we need to know it's a parallelogram first. And then, if we knew that, then we would know it's a rhombus specifically. Part C, given that AB is congruent to DC, so AB and DC, AD is congruent to BC, and that the measurement of ADB and ABD is 45 degrees. All right, so, and we want to prove this time it is a square. So first thing we need to know is we need to know it's a parallelogram. That we do. Because of that information, we have both pairs of opposite sides are congruent. So the next thing I need to know is that it's going to be a rectangle and that it's going to be a rhombus. So we know it's going to be a rectangle because of triangle sum theorem. So since those are 45, triangle sum theorem tells me that this then would have to be a right angle. So then we know that we have a rectangle. So we have at least one right angle. And then also because, get my laser pointer, because this angle is 45 and this angle is 45, we know that this is an isosceles triangle, which then tells us that this side, AB, has to be congruent to AD as well, which then gives me enough information to let me know that this is a rhombus, since I have consecutive sides congruent. And once I know it is a rhombus and a rectangle, I know that this is going to be valid, that it is a square. And part D. We know AB is parallel to DC, AD is congruent to BC. And AC is congruent to BD. So we need to prove that it is a rectangle. So once again, this is going to be not valid because we don't know it's a parallelogram. We do have a condition. This right here is a nice condition to tell us that if it's a parallelogram, then it is a rectangle. But knowing that first part we don't know about the parallelogram, we can't make a valid conclusion. In order for it to be a parallelogram, we either need to know that both this one pair of opposite sides are parallel and congruent, but we don't. We know the separate pairs are. Or we need to know that both pairs are one or the other. So both pairs are parallel, or that both pairs are congruent. So we don't have any of those three conditions. We're very, very close, but we don't, which means it's not a parallelogram, and we can't say that ABCD is a rectangle. All right, for number 3, you want to determine the most specific name for the quadrilateral, then explain your reasoning. All right, this very important question has an important word in it. It says, what type of parallelogram do we have? So we know that these are both parallelograms, which makes our work a little bit easier. So then now we got to just say, is it a parallelogram, rhombus, rectangle, or square? Or is it just that parallelogram that we know? So the first thing I'm going to do, especially when we got a grid, we got to obviously plot our points, and then we want to check the distances. So I did Pythag, so that I know I'm going up 4 over 7, so that I can set up a Pythagorean theorem equation of 4 squared plus 7 squared equals c squared. Solving that, we're going to get that wx is the square root of 65. And I can also do a similar equation to find wz. In doing that, 1 squared plus 8 squared is equal to c squared. And then I find out that wz is equal to the square root of 65. So because both of these numbers are equal, I know that I have consecutive sides congruent. So if we look down here, wx is congruent to wz, which means wxyz is a rhombus, because I have those consecutive sides congruent. So once again, we know we have a rhombus, but now we got to check for a rectangle, which means I need to know if my angle w right here is going to be perpendicular. So I want to look at their slope. So my slope of wx is up 4 over 7, rise over run. And I know my slope of wz is down 8 over 1, so a negative 8. Because these slopes are not opposite reciprocals, they are not going to be perpendicular, which means that it is not a rectangle. And if it's not a rectangle, then it can't be a square, which means the best word to describe it is rhombus, once again, because we have consecutive sides congruent. Very similar process for the second one. We're going to check the sides. Once again, it doesn't matter which pair of sides you pick. Just make sure you pick 2 that are consecutive. So for PQ, I'm going to do 3 squared plus 9 squared equals c squared to get what PQ is. And I get that PQ is the square root of 90. We do the same thing for PS, 2 squared plus 6 squared. That gives us the square root of 40. Since these numbers are not the same, right, square root of 90 and square root of 40, then this is not going to be a rhombus. So then we got to do our check for our rectangle, look at our slopes, see if we have a perpendicular sides, which makes a right angle. So my slope of PQ is going to be up 3 over 9. So if I do up 3 over 9, my slope is 1/3. And for PS, it's going to be down 6 over 2. Down 6 over 2 reduces down to negative 3 over 1, which is just negative 3. And now looking at these slopes, especially this negative 3 over 1 and this 1 over 3, I can see that they're opposite, right? 1 is negative, 1 is positive, and that they're reciprocal. This is 1 over 3, and this one's 3 over 1. So these slopes are opposite reciprocal, which means I do have a right angle there. So that means that PQRS is a rectangle, but since it's not a rhombus, it can't be a square either. So the best name for this one is just rectangle. And number 4 is a challenge problem. Go ahead and take a look at my answer as well for that one. So once again, number 4 is just a challenge problem. You can go ahead, pause the video, and take a look at that answer. Please make sure to also do the LT check that follows and do the 6.4, 6.5 LT check.